Welcome back, Honors Algebra 2, to your last video of the study guide and last video of the year, which means it's like the last time I'll be talking to you guys as a whole, which hopefully, I don't know, I guess I'm like rose-colored glasses thinking that all of you guys are watching these videos, but all I'm going to say, I'm not going to say too much because, I am a lady of few words, but I wish you guys the best. And I know that it has been a rough transition with all of this going on, but you guys have been great. And I've really missed you guys over these past weeks. It's months. I don't know where we're at. I guess it's months now, but I hope you guys have a fantastic summer. I hope you guys stay safe, stay healthy, and most importantly, next year when we are back at school and able to see each other, I want you guys to know that I'm still there. I'm still there to support you. I'm still there to help you with whatever you guys need. So whatever math class you're taking next year, I'm still there to support you in any way that I can. You guys are always welcome to come in and get help. You guys are always welcome to come to tutorials if you need it, like drop by, whatever you guys need. The support is always, always still there for you guys. So just know that if you guys ever need anything, I'm here. And there's that. So thanks for a great, great year. You guys are a great zero period. And I am going to miss you guys. So even if you don't need help, come by next year and say hello. And yeah, there you go. We're going to get through the study guide. Okay, so we are now at the point of solving logarithmic and then exponential equations, which is our last section, 5, 6. So I always like to think about first, what type of problem is it? And number 15 has a log on both sides of the equation. So my first goal is to condense it so there's only one log on each side, which really there is. The only thing I would do is move this to a power. And so that would be, looking for my pen, log of 7x minus 12 equals log of x squared. And so now that we have one log on the left, one log on the right, we can now just set our arguments equal to each other. So we're going to set 7x minus 12 equal to x squared. Now, whenever I see an x squared, we know it's a quadratic, so we know we have to solve that by factoring or using the quadratic formula. So that means you can move the x squared over here. I always like to keep my x squared positive, so I'm going to move everything to this side. So I'm going to subtract 7x, I'm going to add 12, and then I'm hoping I can factor. So do I know two numbers that multiply together to get me 12 and add to get me negative 7? And I do. It's x minus 3 and x minus 4. Now that it's fully factored, I can set each factor equal to 0 and solve. Add 3 to both sides and add 4 to both sides. Remember, you have to check your work. So I plug them back in. 7 times 3 is 21. 21 minus 12 is positive. We're good there. And then 3, we're good there. Plug in 4. 7 times 4 is 28. 28 minus 12 is positive. We're good. And 4 is positive. We're good. So those are both my solutions. X is going to be equal to 3 and to 4. And that is number 15. Okay, let's move to 16. So 16, we have logs on both sides of the equation. So that means I want to condense and I'm going to set arguments equal to each other, just like I did in number 15. So I have 2 logs, so that's a minus. So that means we're going to condense it using the quotient property. And then I have a minus here. We're going to, again, condense it using the quotient property. So that's going to be log base A of x minus 7 over x minus 2 equals log base A of x minus 4 over x plus 12. So because it's minus, it's going to go in the denominator. Same thing here. It's minus, it's going in the denominator. So now I have 1 log on each side of the equations, and now I can set my arguments equal to each other. X minus 7 over x minus 2 is going to be equal to x minus 4 over x plus 12. So we have that, and now we can cross multiply. Sorry, I have something in my throat. There we go. Okay. So to cross multiply, we're just, x plus 12 is going to be multiplied by x minus 7. And x minus 4 is going to be multiplied by x minus 2. And then I can distribute, so just multiply those out. X times x is x squared, plus 12x minus 7x is 5x. And negative 7 times 12 is negative 84. X times x is x squared, minus 2x minus 4x is negative 6x, plus 8. So then it's a quadratic, so that means I want to move everything to one side, but hopefully you guys are recognizing what's going to happen. If I move the x squareds over, they both cancel. And so what I'm left with is 5x minus 84 equals negative 6x plus 8. And now it's just a linear problem that I can solve pretty straightforward. Add the 6x to both sides. I get 11x minus 84 equals 8. Add 84 to both sides. I get 92. Divide 11 by both sides. Nothing simplifies, and that is my answer. And that's it. Okay, so 15 and 16 were both the types of problems where you have a log on both sides of the equation. So that's where you condense and set your arguments equal to each other. 17 and probably 18, 17 and 18 are both problems where you have a log on one side, which means we're going to be condensing and then changing to exponential form. Okay, so that's going to be your first step in 16 or 17 is to condense. You have the same base, they're adding, so what we're going to do is combine those using multiplication. So that's going to be log base 6 of x plus 3 times x plus 4 equals 1. Now that I have one log on one side, I can either multiply now or I can change to exponential form and then multiply. It doesn't matter what order, but I'm just going to change to exponential first. So now that it's condensed, that's when I can change to exponential. So 6 to the first power equals this entire argument. So 6 to the first power equals x plus 3 times x plus 4. So all I did here was I just changed it from logarithmic form to exponential form. So 6 to the first is just 6, and then x squared plus 7x plus 12. Now, because it's a quadratic, just like in 15, we want to get it so it's set equal to 0, so we can either factor or use the quadratic formula. So I'm going to subtract 6 from both sides, and I have x squared plus 7x plus 6 equals 0. And then I can think, okay, can I factor? Do I know two numbers that multiply together to get me 6 and add to get me 7? And I do. That's 6 and 1. And now I can set my factors equal to 0. So I'm going to move up here. So x plus 6 equals 0, and x plus 1 equals 0. So I get x equals negative 6, and x equals negative 1. Now remember, you have to check your solutions. So when I plug this in, negative 6 plus 3, yikes. That gets me a negative number, which means it's a negative argument, which means this is not a solution. Negative 1 plus 3, that works. Negative 1 plus 3 is 2. It's a positive argument. Negative 1 plus 4 is 3. It works. It's a positive argument. So x equals 1. Negative 1 is my only solution there. Okay, let's keep going. So just like 17, 18 is really similar. It has a log on one side of the equal sign or one side of the equation. And so that means we're going to condense and change to exponential. Okay, so when we condense, we have this minus, which means we're going to divide. So it's going to be ln of x minus 8 over 2x plus 1 equals 1. Okay, so then we are then, now that it's condensed, we're going to convert it to exponential. Remember, your base here is e. So when I convert it to exponential, it's going to be e to the first power equals this whole thing. Oops. Okay, so e to the first power equals x minus 8 over 2x plus 1. Okay, so what I would do here is I would get e to the first in decimal form. So e to the first is just e, but I would round it. Remember, when we're rounding within a problem, I would round it to 4 decimal places. So I would do 2.7183. And then I would start to solve for x. So I would multiply both sides by 2x plus 1. Distribute the 2.7183. Right, we're distributing the 2x and the 1. So 2 times e really is 5.4366 x plus 2.7183 equals x minus 8. So I just distributed the 2.71. I'm going to move this x over, so I'm just subtracting 1, which gets me 4.4366x. And then I'm subtracting 2.7183, so that gets me negative 10.7183. And then I am just going to divide. So negative 10.7183 divided by 4.4366 gets me negative 2.42. Okay, so then I go back and check my work. You only have to check your work. Notice I'm only checking my work when the variable is part of the exponent. So 19, 20, 21, I don't have to check to make sure those work. I mean, you can always check your work, but you don't have to check to make sure the argument is negative because there is no argument in 19 through 21. So negative 2.42 minus 8, yikes, that gets me a negative argument. So this one doesn't work, and there's no solution here. And that is it for 18. So I know 18 seems like super complicated, but again, like while you're going through the problem, always round to 4 decimal places and then end your problem with 2 decimal places. That just like leaves less room for error if you have a longer number when you're rounding an exact. Okay, so we have now, so that was our second type. When we have a log on one side, we always condense and then change to exponential. Now, 19 through 21, we have logarithmics, or I'm sorry, we don't have logarithmics. We have an exponential, and we can't get a common base. So whenever you have an exponential and you can't get a common base, that is when we are taking the ln or the log or whatever you guys want to do. I always take the ln of both sides and then solving for x. So I'm going to take the ln of both sides here. ln of e to the 2x plus 5 equals ln of 8. That 2x plus 5 is a power, so I'm going to move it to the front. And I also know that ln of e is going to simplify to be what? It's going to simplify to be 1. So I can really just get rid of that. And so what I'm left with is 2x plus 5 equals ln of 8. And so now I'm just going to get ln of 8 on my calculator. So ln of 8, I'm going to round it to 4 decimals because we're still within the problem. So it's going to be 2.0794. I'm going to subtract 5 from both sides. I'm just doing a lot of this in my calculator, and then I would divide by 2. And I get x equals negative 1.46. And that is it. You don't have to go back and check. Check your work, make sure it's like logical, but you don't have to check to make sure that it doesn't make an argument negative because we don't have an argument in this problem. Or even when we do, the argument is not, or the variable is not part of the argument. So you don't have to check it. Unlike 18, 17, 16, and 15, the variable was within the argument. Okay, let's do 20. So with any exponential, so like with 21, what we're going to do first is you would want to isolate the exponential, but on both sides, the exponential is isolated. So all we're going to do is take the ln of both sides. So ln of 5 to the x plus 2 equals ln of 7 to the x minus 2. Apply the power rule. So bring that x plus 2 to the front. Bring that x minus 2 to the front. And then x minus 2, ln of 7. Now, both sides are pretty basic because remember I would say like move the other ln to the more basic side. Both of these sides are pretty basic, so I'm just going to divide the ln of 7 from both sides. But it doesn't matter. You could have divided by ln of 5 on both sides. It's fine. Okay, so ln of 5 and ln of 7. I'm going to get that. I'm going to simplify that in my calculator. And then x minus 2 is now by itself. So in my calculator, I'm going to do ln of 5 and your parentheses divided by ln of 7. And that's 0.8271. Remember, we're within a problem, so we're rounding to 2 decimals. 8271. I'm now going to distribute that. So that's going to be 0.8271x plus, I'm going to multiply by 2. So that's 1.642. Oh, 65, sorry. Missing numbers. Yep. Equals x minus 2. I would subtract x from both sides. So you can just do like 0.8271 minus 1 gets us negative 0.1729. And you can do these in like, you don't have to do this all in like different steps. And then subtract 1.6542 from both sides. So that would get me negative 3.6542. And then divide both sides by that negative 0.1729. So negative 3.6542 divided by negative 0.1729. And I get 21.13. And there you have it. So another one, I know that the decimals, I'm sure, kind of like freak you out. Don't let them freak you out. Just let it be a number. Use your calculator. I do. I use my calculator throughout the whole process. Just be careful when you're typing in your numbers into your calculator. Don't make a mistake like, I did when I was writing over here. So just take your time, really watch it, and, take your time. Okay. Last one. Yay. Okay, so our last one, we always want to first isolate the exponential expression. So that's the 3 to the 3x minus 5. So when I do that, I'm first going to add 5 to both sides. And then I have 2 times 3 to the 3x minus 5 equals 16. I still want to isolate that exponential expression. So we can't combine these. We can't do that. They're not common bases. So we would have to divide both sides by 2. And I get 3 to the 3x minus 5 equals 8. And so now I'm at a problem like number 19 or kind of like 20. But what I'm going to do now, I have the exponential expression isolated. I'm going to take the ln of both sides. So ln of 3 to the 3x minus 5 equals ln of 8. I'm going to apply my power rule and move the 3x minus 5 to the front. I am then going to, you know what I'm going to do to make this a little bit easier, I'm going to divide both sides by ln of 3 now. You could have gotten ln of 3, distributed it, gotten ln of 8, just moved everything, but I'm just going to do it this way because then I can get kind of an exact number more so. It's less rounding. So 3x minus 5, and now I just did that in my calculator. So ln of 8, end your parentheses, divided by ln of 3, which is 1.8928. I'm going to add 5. Oops, you cannot see that. So that gets me 6.8928 and then divide by 3. Notice how I kept everything in the calculator so I didn't ever have to round really. That's what helped with dividing both sides by ln of 3. So when I divided both sides by 3, I get 2.297. That 7 rounds the 29 up to a 3. Oh. And that's my final answer. And that's it. That's all she wrote. That's all she said. That was the study guide. So I hope you guys have a great day. I hope you guys have a great summer. I know that we're still going to obviously be in contact, but this is your last instructional video from me. So yeah, like I said in the beginning, if you guys really ever need anything, please feel free to, drop by if we're at school, or if it's during the summer, you guys can always email me. I'll keep that phone number available. So if you guys need anything, you guys can always contact me. Yeah, so I hope you guys have a great summer. I hope you guys have a great day. Please let me know if you guys have any questions on chapter 5. I'm here to help. There you have it.